Okay, it's 10:30. We have for line fifth Itnl Seminar today. And today, Ms. Alicia will present about FAO report, the title of the Microplastics in Fisheries and Aquaculture. Please, Alicia, the floor is yours.
Hello, good morning. Today I'll present FAO Technical Report 2017, Microplastics in Fisheries and Aquaculture, Status of Knowledge on the Occurrence and Implications for Aquatic Organisms and Food Safety. Today I'll only present about abstract and chapter 1. So this report is a collaboration between UNEP, GESEM, FAO and other partners between 2014 and 2016. The aim was to improve the knowledge base on microplastics in the marine environment and provide policy advice on this topic. Partners contributed to the global assessment on sources, fate, and impacts of microplastics on the marine environment and resources with funding provided by the government of Norway. FAO specifically was requested to contribute on fisheries and aquaculture to assess the potential impact of microplastics on consumers' health and perception, as well as to understand the potential consequences on fish productivity, which are likely to be affected by microplastics. So this report was drafted in 2016 and published in 2017. So since the data is slightly outdated, I searched for latest data for certain parts and have provided them in the slides. Updated data will be written in purple and sources are shown on most slides. For future reference, here are the 3 sources that I mainly took from. The first is FAO's 2022, the State of World Fisheries and Aquaculture Report, which presents updated and verified statistics of fisheries and aquaculture and analyzes its international policy context and selected high-impact actions undertaken to accelerate international efforts in support of the SDGs. This report cites a lot of PlasticsEurope, so I also included the latest report. Plastic the Facts is an analysis of the latest data related to plastic production, demand, conversion, and waste management in Europe. It provides information on key figures of the European plastics industry and gives an insight into the industry's contribution to European society. And then finally, because PlasticsEurope doesn't include fiber in their report, I also looked for the latest report from Textile Exchange, which is a global non-profit that creates leaders in the preferred fiber and materials industry. Preferred Fiber and Materials Market Report is a comprehensive annual publication on fiber only. So this is the abstract for the report. Each paragraph here is related to each chapter. So in the first chapter, it starts with information about plastic production and introduces the idea of ALGFG and plastic. In the next paragraph, it is about microplastics and definitions of microplastics and how microplastics enter aquatic environments through fragmentation. Then in the next chapter or paragraph, it discusses about injection of microplastics by aquaculture organisms, included species of commercial importance for fisheries and aquaculture. And then in the next section, the report discusses about chemicals in microplastics, such as additives and accumulation of persistent bioaccumulative and toxic contaminants that have been perceived to be a hazard and risk to marine environment. And then moving on, the next 2 chapters are about effects of microplastics towards aquatic organisms as well as towards humans. And then finally, in the last section, it is about knowledge gaps and future research needed on the possible effects of nano and microplastics on food safety. So this is the contents of this report. As you can see, there are many chapters. So for Ocean's weekly seminar, these chapters will be split into 4 weeks throughout October. This week, I will present only the abstract and chapter 1. Then next week, Yuna will present chapter 2 and 3, and Josu will present chapter 4 and 5, and so forth. However, as you know, only the first week of the month for Ocean's weekly seminar is in English, so the rest of the seminars will be in Korean. So if you're interested, you can tune in, or you can read the report on your own time. So chapter 1 is general introduction. 1.1 is about context, so specifically about fisheries and aquaculture production and plastics and microplastics. So production of fisheries and aquaculture has increased approximately 8-fold since FAO started to compile data from member countries in 1950. This production has outpaced human population growth during the last 5 decades. In 2015, production reached a record high of around 170 million tons of animal products without considering an additional of approximately 29 million tons from farm aquatic plants. In 2020, the total fisheries and aquaculture production reached an all-time record of 214 million tons, comprising of 178 million tons of aquatic animals and 36 million tons of algae. Approximately 57 million people were engaged in the primary sector of fisheries and aquaculture in 2015, and this increased to approximately 58.5 million people in 2020. In 2014, international trade of seafood represented around 9% of total agriculture exports and about 1% of total world trade in value terms. The total world merchandise trade remained at 1% in 2020, but the international trade of seafood increased to 11% of total agriculture trade. For marine capture fisheries, the data has fluctuated around a mean value of 82 million tons, reaching 82.3 million tons in 2015 and 78.8 million tons in 2020. If you see the figure on the right, you can see that in 2018, here, it is still at 84.5 million before decreasing again. So this decrease in marine captures was severely affected by the disruption to fishing operations caused by the COVID-19 pandemic during 2020. Inland capture fisheries have been increasing steadily, shown in pink or red here, and showed a value of approximately 11.5 million tons in 2015 and have fluctuated since then. In the 2022 FAO report, 2020 data shows that it is still at 11.5 million tons, but is said to have decreased by 5.1% from the total global catch in 2019. For marine fisheries, the most productive areas in 2015 were the North Pacific, the Central Western Pacific, and the Northeast Atlantic. In 2020, the most productive areas were still in Northwest Pacific. In the 2017 report, FAO writes these productive areas in general, but in the 2022 FAO report, it splits more specifically and writes which country in each of these areas contribute to the most production, such as, for example, in Northwest Pacific, China is the most productive. So if you are curious, you can check the report out. Major fishing nations in 2015 were represented by China, Indonesia, America, Peru, Russia, India, and Japan. And these 7 nations accounted for approximately 52% of global marine fishery landings in 2015. Based on 2020 data, the latest major fishing nation data are represented by China, Indonesia, Peru, Russian Federation, America, India, and Vietnam. These 7 nations accounted for approximately 50% of global marine fisheries landing in 2020. There are not much changes between these two data. Overall, most marine capture fisheries productions increased except for China, Japan, and Vietnam. For China, despite the decrease in fisheries production, China was still ranked first in production. Vietnam was introduced into the top 7 in 2020, but actually both Vietnam and Japan contributed to 4% of total global marine capture fisheries in 2020. And here, Japan was actually only lower by 0.1 million tons than Vietnam. So Japan was actually ranked number 8. For aquaculture animal production, it increased from around 0.6 million tons in 1950s to 4.7 million tons in 1980, to 77 million tons in 2015, and 87.5 million tons in 2020. as shown in the figure here. It should be noted that these numbers exclude algae, so ignore the highest green one. In 2015, it seemed that it is estimated that 18.7 million people are employed in the primary sector of aquaculture, of which approximately 84% were in Asian countries. These statistics were the same for 2020. The top 25 aquaculture producing countries accounted for about 96% of total world production in 2014, of which the 5 major producers were Asian countries. These 5 major producers itself accounted for 81% of total productions. In 2020, the contribution percentage of these 5 major producers increased to 91.6% of global aquatic animals and algae. There were no changes to the top producing countries in 2015 and 2020, apart from the amount of aquaculture production. These countries were China, India, Indonesia, Vietnam, and Bangladesh. On a world scale, the contribution of aquaculture to total fisheries and aquaculture production, excluding algae, has climbed steadily, reaching 42.2% in 2020, which is on par with capture. This represents a major change from the 4% share of aquaculture in 1950s, 5% in the 1970s, 20% in 1990s, and 44% in 2010. Asia continues to produce more from aquaculture than from capture, and when a top producer is excluded in each region, Asia still has a high aquaculture share of 44.7%. Inland aquaculture production amounted to about 48 million tons in 2015, which represented around 63% of total aquaculture production. Inland production was dominated by several species of fish, such as carps and tilapias. And then for 2020, as shown in the table here, the inland aquaculture production amounted to 54.4 million tons, which represented around 62.2% of total aquaculture production. Finfish still dominates the inland aquaculture production for both 2015 and 2020. In 2015, marine and coastal aquaculture produced about 28 million tons, of which mollusks represented 65%, followed by crustaceans and finfish. In 2020, the global production of marine and coastal aquaculture increased to 68.1 million tons, which is more than half of the amount in 2015. Now, algae ranked highest at 51.4%, followed by mollusks and finfish. Moving on to plastics and microplastics, plastic production has increased substantially since large-scale industrial manufacture started in the early 1950s. Almost all aspects of daily life involve plastics. In the European Union, based on PlasticsEurope 2016, for example, the main applications of plastic include packaging, building and construction, automotive industry, electrical and electronic, agriculture, and other applications as shown here on the left. The right here is the updated data from PlasticsEurope 2022. Here you can see the percentages are actually almost the same, only slightly increased. Now in the latest data, there is the additional section of household, leisure, and sports, which previously the data didn't have. So in this section, the report explains what is microplastics. What they report is that microplastics commonly defined as being 5 mm or less in their longest dimension and have been found in different environmental matrices. In freshwater and marine environments, microplastics have been found in beaches, shelf, and deep water sediments, and in surface and subsurface waters. Microplastic contamination is not a new phenomenon, and the first observations of their occurrence actually date back to the 1960s. However, it is only in the last decade that increased attention has been given to the problem. This has primarily been driven by environmental and human health concerns, particularly with fish and fishery products, which may have been contaminated with microplastics and their associated contaminants. These concerns are based on potential implications for food safety and human health. Based on Plastic Europe, the 2015 plastic production reached 322 million tons, while the 2021 plastic production reached 391 million tons. In the 2017 FAO report, projections based on the 2015 plastic production growth indicates that the plastic production would double by 2025, but as of 2021, the growth rate, fortunately, did not double as predicted, as it is still in the 300 millions mark. Surprisingly, Plastic Europe excluded synthetic fiber into their report. So in the 2017 FAO report, they discuss about this exclusion of fibers. So synthetic fibers constituted a large part of synthetic polymer production, and the 2015 worldwide production was about 61 million tons, and in 2021, 72.2 million tons. Synthetic fibers have replaced natural fibers such as cotton, wool, and silk because of their low price, mass production, and customization as shown in figure 1.3 here. And then if you see the figure on the right, you can see that as of 2021, synthetic fiber constitute of 72.2 million tons and at 64% of global fiber production. It's quite blurred, sorry. And then mass production and mass consumption of plastics have led to the accumulation of plastics in natural habitats and adverse impacts on biota and the economy. So environmental impacts include habitat damage, entanglement and ingestion of marine litter by biota, and the introduction of non-native species through rafting on floating litter. And then economic impacts of marine litter includes loss of income, cost of cleanup, reduced fishery stock, and reduced tourism. Marine litter can also cause navigational hazards for fisheries and shipping. So plastic production and its waste generation are related to human population growth. As such, microplastic contamination is very likely to increase in the foreseeable future as a result of environmental breakdown and fragmentation of present stocks and future production of plastic items. Plastic production contributes to the generation of greenhouse gases that drive climate change. It is expected that increased temperatures will modify the partitioning of environmental contaminants into different matrices, such as air, soil, water sediments, and plastic debris, and may enhance the toxicity of certain compounds such as persistent organic pollutants, but will also likely increase the rates of chemical degradation. As the degradation and fragmentation of plastic debris is temperature dependent, increased temperatures will likely affect the generation of microplastics and nanoplastic particles. So the purpose and target audience of this report is shown here. Microplastics are widespread in the marine environment and have been observed in seawater, lakes, rivers, estuaries, sediments, and many species of biota. Concerns have been raised that the presence of microplastics and their associated chemicals represent a risk for fish productivity, fisheries resources, and may result in contamination of foodstuff. The presence of microplastics in the environment and in foodstuff, including fisheries and aquaculture productions, creates a need for assessing environmental, ecological, and human health risks. So this report summarizes the current state of knowledge on the occurrence and impacts of microplastics in commercial species of finfish and shellfish, in prey species, and in products of fisheries and aquaculture. It provides an assessment of potential risks to fisheries, aquaculture, and human health due to the presence of microplastic and nanoplastics in the marine environment. The aim of this report is to provide a more reliable evidence base for a wide range of organisms and stakeholders to be used in developing appropriate advice and possible measures to reduce exposure to microplastics of fish resources and consumers. And finally, the target audience for this report includes fisheries scientists and managers, health authorities, fisheries and aquaculture associations, environmental and fisheries ministry, regional fisheries bodies, and regional sea organizations. And then the structure and scope of this report is that this report presents an overview of plastic production, the types of plastic and their chemical constituents, as well as the contribution of plastics to marine litter, and particularly the contribution of fisheries and aquaculture activities to the generation of marine litter. The report also covers what is known on intake and ingestion of microplastics by aquatic organisms, including commercially important species. The report briefly presents the human health benefits associated with the consumption of fisheries and aquaculture products. Furthermore, the human health issues related to the presence of microplastics and nanoplastics in fisheries and aquaculture products is discussed, and the risks associated with the ingestion of microplastics and nanoplastics is assessed. Finally, here are some useful information or links that I used in this presentation. So if you are curious, feel free to check it out. That's all for my presentation. Thank you.
Thank you, Alicia. Thank you for your presentation and updated information. As Alicia said, this report has some old-fashioned data, but Alicia showed a report. This is the World Fishery and Aquaculture. It's not about the microplastics. I thought about changing the report, but I thought this report focus on the microplastics, and microplastics information should be changed a lot about the impact on the organisms, and some size definition for nanoplastics is different from papers in this report. So please, if you are curious about the data, tell us now, or search the information while Googling. Thank you, Alicia, again. And let's have a discussion time. If you have any questions and opinions, please feel free to tell us.
I found out this report has an abstract and also executive summary.
Yes.
Usually, I think we only have an abstract or executive summary, but this report has a abstract and also executive summary. What is difference, or what is the purpose of the authors to include both of section in this report?
The abstract is the contents in the summary is actually more detailed compared to the abstract. So abstract is just, I'm going to talk about this, but then in the summary, it summarizes the contents in the chapters. So yes, more information in the summary.
Yeah, I found out that executive summary is actual summarization of all the contents of the report. It was very helpful for understanding the contents of this report. Thank you.
Thank you for your question. Any other questions? Yes, Dr. Sunny.
Thank you very much for the presentation. It's not about a question, it's a comment. It's okay. Thank you. Actually, aquaculture is our main concern in Korea because it produces a lot of macro and major microplastics. But when we think about the global situation, there are not very well-defined data or report. So that's why we chose this report. And I really appreciate the Alicia updated the contents in comparison with the newly published report by FAO. As we can imagine in the recent publication, it doesn't deal with the microplastic in detail. It means we don't know much about the microplastic production from aquaculture gears, and aquacultures in every different countries use various and different types of gears. So we don't know much about that internationally and in Asian region especially. So I just want to know more about the aquaculture gears, which the Asian countries usually deploy in each region. For example, in Korea, the major concern is styrofoam buoys used for oyster and seaweed, one type of seaweed. But when I think about the shrimp aquaculture in other countries, it doesn't require a lot of aquaculture gears with synthetic materials. So there is some need requirement to integrate all the information about the aquaculture gears in the world. So we need to be more interested in this area, in these industry areas. So that is my comment.
Thank you, Sunny.
Excuse me. In addition to Sunny's comment, I've shared the link of the report from APEC on the review of a regulatory framework on microplastic in APEC countries. Actually, Jong-soo and I participated for the preparation of this report on Korea's situation. So you can check the content of this report and you can understand how APEC countries are addressing microplastic generation from aquaculture industry in this region.
Thank you.
But not that comprehensive. So, like a quick rapid assessment of a regulatory system of the APEC countries.
And microplastic issues is still discussing and it will be updated and progressed, I think. Please refer to the paper. It may be helpful. And other questions and opinions related to the issue or other general opinions will be welcomed. Microplastic issues is complicated, I think, and maybe in the water column or water surface, it doesn't produce much of the microplastics compared to the beaches, maybe, because it's under the water and it's difficult to measure. So we have to discover a lot, I think.
There are no more questions or comments. I will add some facts based on our research result in Korea. In Korea, microplastics consist of mainly two major components. One is EPS, it means polystyrene, foamed polystyrene microplastics, and the other is polypropylene fragment. So we can easily imagine the source of the foamed polystyrene of microplastics. but the polypropylene fragments can come from aquaculture and capture fisheries. So we guess it can be originated from ropes. So we don't exactly know at the moment, but when you think about the amount of gears, probably ropes from aquaculture can be a major source of polypropylene fragments, which are mostly appeared in the small microplastic sizes, like less than 1 millimeter. So from the field survey data, we can guess the styrofoam buoys and ropes could be the major source of microplastics. So it is from our recent research result. So which ocean assigned those two things are part of our top 10 priority items which we focus on. That's why. Okay, thank you.
Thank you, Sunny. Is there any opinions from outside Korea? Outside of Korea?
Oh, I have one more
Okay,
thing
Ellie.
to share. Actually, I forgot about this. I read it recently, but I forgot to add. In UN actually published this World Ocean Assessment. It has 2 volumes, volume 1 and volume 2. And then you can actually read a lot of information here. And then in volume 2, that actually talks about, oh, where is it? Oh, sorry, I can't find it now. The effects and all this information from the current state of these marine industries and yeah, sorry, human health affected by oceans, and it's also related. It also has aquaculture and fisheries information here, so you might want to check this out as well. It's free.
And the second World Ocean Assessment also has a marine debris part.
Yeah.
Yeah.
In this book or other books?
In this book.
In this book, okay.
Aquaculture,
Yeah, chapter 16, changes in aquaculture.
seaweed harvesting.
Okay.
Yeah. I will
Okay.
share in the chat.
You can find more information as Alicia suggested for reading. Chat about.
There is comment from. I wonder if we find that a major source of microplastics are from fisheries such as rope fiber. Are there known alternatives for the industry?
Actually, I don't know about this. Do you have any? Do you know any alternatives for? Yeah, because in recent decades, the natural fibers is changed to the synthetic fibers, like for net or ropes. So in this stage, we are thinking about the recycling of the rope and net, because we can, it's difficult to find other alternatives.
But in Korea, we have
Turn on your mic.
fishing nets. Fishing nets are replaced by biodegradable fishing nets, only nets. But some specific types of nets are being replaced by the government and governmental research institute.
And there are debates about biodegradable materials, because it's really biodegradable or not. As far as I know, it's like a worldwide debate about the biodegradable materials. So maybe future time they will tell us. for more detailed information. But right now, we don't know what the truth of the biodegradable materials.
Usually, researchers insist biodegradable nets can be degraded into water and CO2 completely, but which is possible only in the laboratory condition, and it takes 2 or 3 years to be degraded. It means it can impact at least 1 or 2 years on animals or navigation. So it implies biodegradable nets, fishing nets, cannot be a part of solution to reduce the impact. That's my comment.
Yes, thank you for your comment, and thank you for asking, Ms. Sarah Euler. And any other opinions or questions? Okay.
Hi. Sorry, I don't know if you can hear me. This is Boris from Green Hub in Vietnam. Yeah. Just in terms of sources of information, sources of microplastics, there's a very direct link between the capture fisheries and aquaculture. So unfortunately, most FAO tends to separate the two as being independent fisheries, but a lot of fish feed for aquaculture species, lobster, shrimp, etc., are actually from marine fish. So that is a very, I think, important source of a possible source of microplastics or nanoplastics. They're not unconnected at all. In some countries, they're called trash fish, and up to 100 species of marine fish are used for aquaculture species. But there are also, I think, sources outside of the fishery sector. The sewage from land-based sources that have microplastic coming through rivers and canals and tides and storms and stuff like that. Normal erosion of land that releases microplastics when the sediment becomes active and not buried underground. That's another possible source of microplastics that I saw 1 or 2 papers on that. So somehow all these parts have to be connected to give a truer picture. And in terms of within the aquaculture sector, I mean, I think almost everything in aquaculture now is based on plastic. Very few things are based on non-plastic issues, whether it is the pipes, the PVC pipes that bring water into the systems, and because of the shearing effects of the water pressure on the plastic, microplastics get squeezed out of the pipes, or the bags or the bins or packaging. So it's very hard to identify exactly the single sources of microplastic origins. I think also in terms of finding out where they may come from, probably the best sources are things like fisheries trade magazines or fisheries trade shows that actually you can see the different types of materials that are being advertised. Of course, a lot of it is advertisements. You're not so sure exactly how much of it is accurate. We were just talking about biodegradability and what that means. That means different things to different people, no? Because just because we cannot see something, it doesn't mean it's gone. It could still be there in another form. So people have sometimes a very casual interpretation of the word biodegradable, which when you examine it, really is not biodegradable at all. Either it has to be converted into some other chemical or depolymerized or converted to carbon dioxide or something, but it's still there. So the impacts need quite a comprehensive life cycle analysis. So just a few comments. So thanks very much.
Okay, thank you for your comment. And actually, that's true. It's very difficult to track the sources of the microplastics, especially in the water column. But we can guess there are many ALDFGs in the water column and in the water, so they may produce a lot of microplastics, especially for styrofoam buoy in Korea or lobes. And 2 or 3 papers from England, and they tell us about the operation of the lobes while they are operating the lobes, not ALD lobes. Actually, I mean the lobes produce a lot of microplastics while operating the lobes. Thank you for all comments. I understand there is no more questions and opinions. Let's decide. Yeah, this paper, Alicia found these papers. It's about production of microplastics while operating. Yeah. Alicia will share this paper to the chatting or? Please remember this paper is potential microplastic release from the maritime industry of region of lobe. And on 1 or 2 papers I read for similar topic. Okay, thank you for participating in this seminar.